Nowadays, is it okay? Is it okay now? Yeah, I feel some network heavy since morning only this problem is there, beta. Okay, okay. Pray to God that it should be okay only. I want the network to be very good so that I can teach nicely. Okay? Now let's start, beta. Now look here. So the hydrogen is going to give one and chlorine is going to take one, beta. So the giving and give and take policy is there. Okay. And because of that, beta, what happens here is HCl will be formed. Now next one what we have seen is sulfur. So hydrogen is exactly going to give one, but sulfur need two. Sulfur is needing how many, beta? Sulfur is needing two. Okay. So sulfur is needing how many? Sulfur is needing two. So since sulfur is needing two, what we will do? We will apply crisscross rule. So it will become H2S. Got it? First one and second one, note down, beta. This is the first one. Got it? And this is the second one. Note down this first one and second one. Will you be able to write down, beta? Okay, very good. Tanisha, join everyone. So this is first one and second one. Is it visible, beta? So that means one is giving, another one is taking, beta. So here, very good, beta. So now look here, this is the most important part. One is giving, another one is taking. So hydrogen is plus one, chlorine is minus one, HCl. Now hydrogen is plus one and sulfur is two. So definitely, yes, I am going to teach, beta. I am going to teach again one more time. Check this one out, how we are doing it. One more time, check. So hydrogen valency is what, beta? Hydrogen valency is plus one. Means hydrogen is ready to give. Okay. Now chlorine needs one. So minus one. Here plus and minus is not important. You see the crisscross rule ratio. This will go here and this will go here. Hydrogen 1, chlorine 1. So it will become HCl. Whereas if you will see hydrogen and oxygen. So hydrogen is plus 1, oxygen valency is minus 2. Again you apply crisscross. So 2 will go here. That means 2 atoms of hydrogen will combine with 1 atom of oxygen. Understood? So this is exactly coming as H2O. Third one, beta, when hydrogen and sulfur will be there. So here hydrogen will again plus 1, here minus 2. Again crisscross rule will be there. How much it will become, beta? H2S. I hope now it is okay, beta. Now next one is one by one we will see and we will note down. I hope you might have understood this one, beta. So this is exactly 3 examples. At least 50 examples we must write. Okay. Understood now, beta? So at least 50 examples we must write so that we can understand crisscross rules very nicely. So 50 examples we must have in our account to understand crisscross rule. Okay. Now, beta, we'll go for second one, hydrogen and SO4 2 minus. Understood? SO4 2 minus means this 2 minus will come here, beta, and hydrogen will have here plus 1. So now again crisscross rule will be there. This will go this side, this will go this side. It will become H2SO4. I hope you might have understood how to write this one, beta. So one time hydrogen is exactly getting 2 and sulfur is getting 1. So sulfate. So definitely, yes, understood now? Note down, beta. Note down, everyone. Please kindly note down, children, how to write this one. Yes, super. So this is coming as H2SO4. Yes, super. Understood now? This is the simple one. Now we will go back to our content, please. So what was our next content was? So we wrote HCl, this part we over, hydrogen sulfate, sulfuric acid is over. Now beta, sodium nitrite. Sodium nitrite we are going to write, sodium nitrate and aluminium phosphate. Okay, sodium nitrate and aluminium phosphate we are going to understand. So sodium nitrate, when we are starting sodium nitrate, how we are going to write? Sodium nitrate. So when sodium nitrate somebody will give, so nitrate, sodium is exactly having plus 1. Nitrate is having NO3 minus. So definitely it is coming as -1. Again crisscross rule, so it will become NaNO3. This is called as sodium nitrate. Got it? This is called as what beta? Sodium nitrate. Now comes ammonium phosphate. Understood? Aluminium phosphate. So for aluminium phosphate, aluminium is exactly having 3 plus and PO4 3 minus is there. So 3 minus. Correct? Now beta, according to crisscross, this will go this side and this will go this side. So Al will have 3, PO4 will also have 3. So 3:3 ratio, I told you now, when same ratio will be there, it will get cancelled. So it is coming as AlPO3. So direct it is coming AlPO3. PO4. Understood? Aluminium phosphate. Note down this one, beta. This is considered as aluminium phosphate. Children, did you noted it? Note down, please. Aluminium phosphate. Note down nicely. Yes, aluminium phosphate. Note down. Take your time and note down, beta. Done? Very good. So shall we go for the next one, beta? We'll go for the next one, beta. Next one we will do. So aluminium phosphate we have done. Now aluminium sulfate and ferrous sulfate. Aluminium sulfate and ferrous sulfate. Aluminium sulfate and ferrous sulfate. Now let's check this one out. Aluminium sulfate and ferrous sulfate beta. So once time we are going to check aluminium is how much aluminium valency is there? 3 plus. And sulfur valency, sulfate valency is 2 minus. So minus 2. Cross do. So it will become Al2SO4 3. This is called as aluminium sulfate. Note down beta. Hi Prince. Sorry, Himanshu. So now ferrous sulfate. Ferrous sulfate means Fe plus 3 SO4 2 minus. So minus 2 beta. So it will become Fe2 SO4 3. Note down this too. Good evening, Himanshu. So Fe2 SO4 3. Check this one out, beta. Aluminium sulfate, ferrous sulfate. Now, children, you are understanding how to write, beta? How to write the crisscross rule. Did you understood how to write, beta? Come on, very good, super, super. Name also beta, sulfate, sulfide, whenever we are writing, yes. So it's very, very important to note down these things beta. So now sulfate, sulfide, when we are writing, we need to understand this one. So see, aluminium sulfate, check this one, aluminium sulfate, Al2SO4 3. After that, what is there? Ferrous sulfate. Ferrous sulfate is Fe2SO4 2. Okay, ferrous sulfate, ferric, now ferrous is there. Ferric sulfate is Fe2SO4 3. So name I have to change, ferrous sulfate. Now potassium dichromate. So when somebody will ask you about potassium dichromate, how we are going to write beta? For potassium dichromate, potassium is +1. Chromate. So chromate is exactly having Cr2O7. So here it will come -1, -2 because it is -2 there. So this -2 and this part. So it will come K2Cr2O7. K2Cr2O7. Is it visible beta? K2Cr2O7. Evening abhi class hai beta. K2Cr2O7. Is it visible? K2Cr2O7. Here one small change is needed beta, ferrous and ferric sulfate. I'll do it right now. Ferrous and ferric sulfate. Ferrous means 2, ferric means 3. 1 minute, I need to change one thing, beta. Ferrous and ferric sulfate. Ferrous and ferric sulfate. Check here. Ferrous and ferric sulfate when we are doing. Yes. So beta, when ferrous and ferric sulfate we are doing, check here this time. So ferrous part is Fe. Here 2 is there. Okay. 2 plus. And sulfate is SO4 2 minus. So minus 2. Crisscross. So here it will become FeSO4. This is what beta? This is FeSO4 is coming as ferrous. Ferrous. Just change this one, beta. There plus 3 I wrote. You write there. Yes. Ferric means 3. Correct only. Us means 2. Ik means 3. Us means 2. Ik means 3. Us means 2. Ik means 3. Okay. Ferrous, ferric. Note down, beta. Just change that part. Us means 2. Ik means 3. So ferrous and ferric sulfate. Ferrous and ferric sulfate. Understood, beta. Ferrous, then ferric sulfate. Now we will go for the next one, beta. So now potassium dichromate. Ferric means what, beta? Ferric sulfate is that what we have written, na? Fe3. That part will come. Sulfate is 2. So Fe2SO4. That is name only we will be changing. Now, beta, look here. This is the most important thing. So when sodium chloride is there, so sodium is having plus 1, chlorine is having minus 1. So sodium plus 1, many books they are writing here plus minus. So first write plus A plus 1 plus 1 minus. So 1 1 is going. Potassium bromide. So sorry, potassium bromide. So potassium full name is coming. Bromide, ide we are adding. So potassium bromide, hydrogen chloride, aluminium oxide, Al2O3. Will you be able to do aluminium oxide? How we are doing aluminium oxide? This is ferric sulfate, beta. Ferric sulfate. Now, aluminium oxide. So if somebody will give you aluminium oxide, how we are going to write aluminium oxide? Aluminium is exactly 3 plus. Okay, I'll write plus here. I am writing plus here. Now you write plus there. Oxygen 2 minus. So here crisscross is coming. So it will become Al2O3. This is aluminium oxide. So some books they are writing front, some books they are writing back. So you just write back of it. So aluminium oxide. Okay. Is it done, beta? Yes. Al2O3. Absolutely super, beta. So now are we going to go for the next one, beta? Let's see, check this one out. We will go for the next part. So when we are writing the next section, how we are writing the next part, beta? So now they are telling that in the formula of compound, the valency one is normally omitted. We need not to write one. You see here, until biology, you left one chapter. I need to teach, beta. I need to teach. Still chapter is there in science. Chemistry I'm doing very slowly because you need to study. After that chemistry I'm going to start gravitation again. In gravitation, most important part is left: work, energy and force I have to teach, sound chapter I have to teach. So I'm going, because these two chapters are very heavy and you must write it very nicely. So only I'm just going little slow, because now we are in a verge to finish this one beta. Mostly the chapter is going to be finished soon, because atomic number, this part, once it is there, you tell till where the chapter is there, because here more things are present. So molar mass is there or not in the chapter, only crisscross rule is there means we will start next chapter beta. Crisscross rule is there means we will start next chapter, we will not be wasting time. So you need to just send me the syllabus, what and all things we have to study. Okay, so now look here beta. So whenever whenever sodium and hydrogen is there, in chemistry only one chapter is left, and beta in physics three chapters are left. Okay, biology one chapter, you need to send me which chapter is there. Food resources, now that I'll explain, no problem. So now sodium one chapter, sodium is one, so we need not write sorry, nitrogen is one, so we need not to write it. We only have to write it CC. Wherever one is there, it is not needed to write. What we need to do, only NH3 is enough. Okay, only NH3 is enough. In case there is some other factors will be there, then it will be taken. Like carbon also beta, you see C2H4 is there, then we are writing CO2. C2H4 means simplest form we are writing, it is coming as CO2. Okay, now beta tell me, mole concept is there or not, till where? Can you send me pages of your atoms and molecule chapter, so that I can take the screenshot of that chapter and send me as quick as possible, so that I'll come to know till where I have to teach. Okay. So now beta, for example, ammonia is the molecular formula, while NH3 is the common. So we already know this one. Now some compounds. So some compounds we are writing like that only. Now children, are you ready for aluminium hydroxide? So if somebody will tell you to write aluminium hydroxide, how you are going to write aluminium hydroxide? Now look here, aluminium hydroxide, when you are going to write, you check aluminium is having 3 plus, okay, and hydroxide is having 1 minus. When you will do crisscross, it will become Al will have 1. If 1 is there means need not to write, and OH is having 3. So AlOH whole twice. So this is aluminium hydroxide. Note down beta. For aluminium hydroxide, maximum this much only will give. More than this they will not give. So maximum this much is exactly there in the target. So aluminium hydroxide is AlOH whole thrice. And they will be writing like this. Very good beta. Hi beta. Ramchandra. Can you tell me your name beta? Mole concept is there. Okay beta, just take the screenshot and send me. Yes. Now beta, second one you check, HS is there. So hydrogen sulfide. So here's hydrogen sulfide is there. Okay. So hydrogen sulfide. Sulfur is exactly 2. So here what we are going to write, H2S. So it is considered as what beta? Hydrogen sulfide. What we are going to consider is that hydrogen sulfide. Okay. Now next one is beta, ammonium sulfate. When ammonium sulfate we are writing, ammonium is NH4. Yes, ammonium is NH4 1 plus. Sulfate is SO4 2 minus. So it will become NH4 will take 2, sulfur will take 1. So NH4 to S4 SO4. NH4 to SO4. Note down this one beta. This is most important. Come on children, note down this one. Ammonium sulfate. Now itself write the name and finish it up. Ammonium sulfate. Ammonium sulfate is coming how beta? NH4 1 plus. So 1 plus is here. SO4 2 minus. So here 2 minus is here. And then crisscross done, NH4 to SO4 only. Understood? So note down this one beta. So these are some of the particular peculiar names you need to remember. Note down this one beta. Come on, note down this. Then we will go for the next one. हाय रुचि, क्रिस क्रॉस रूल को अच्छे से समझ करके लिख लो ठीक है, मतलब क्रिस क्रॉस रूल का अगर कुछ भी होगा तो उसको कंप्लीट कर लेना। हम्म Now is it okay, beta? Screen. Now next one is sodium carbonate. Sodium when you are writing little bit big कर देते हो ना, ठीक रहेगा. So now look here, beta. Sodium carbonate. Sodium is plus, beta, 1 plus. Carbonate is 2 minus. So Na2CO3. That is called as sodium carbonate. Now calcium. Calcium is plus 2, beta. And you know that phosphate is 3 minus. So Ca3PO4 2. So just crisscross it will be done. It will go crisscross and it will be written like that. So you must note down these things. And next is potassium chromate. Potassium dichromate or potassium chromate. So if you are writing potassium, K2Cr2O7 is potassium dichromate. K2Cr2O7 is potassium dichromate, but K2Cr O4 is exactly coming as potassium chromate. Up to formula unit mass. One time, beta, take the screenshot and send me. Take the screenshot once the class will be over. Take the screenshot and send me, beta. Okay, then what you call, then I'll be able to create some more chapters and write for you. So this is exactly what, beta. Okay, so this is called as potassium chromate. What is the difference between potassium chromate and potassium dichromate? Potassium chromate is K2CrO4 and potassium dichromate is K2Cr2O7. Understood? So that is the difference between potassium chromate and potassium dichromate. This is the difference between, beta, potassium chromate and potassium dichromate. So potassium dichromate, if somebody will write, means what they will write? K2Cr2 potassium dichromate. K2Cr2O7. This is potassium dichromate. And potassium CrO4 is potassium chromate. Potassium chromate, potassium dichromate. This is the difference, beta, between potassium chromate and potassium dichromate. Beta, today itself you prepare for 11th. That's the most important thing. So whenever crisscross rule will be there, any ionic compound will be given, positive and negative ions will be given, you can easily be able to note down, beta. See how easily it is written. Sodium and carbonate is there. So when sodium and carbonate is there, we know that sodium valency is +1 and carbonate valency is CO3 2 minus. Understood? So it will become Na2CO3. Understood, beta? Here calcium phosphate is there. So when you are writing calcium phosphate, calcium Ca3PO4 2 minus, it is coming as what, beta? Calcium phosphate. Calcium phosphate. Now, beta, potassium chromate, I have already explained you. Now we will go for, now we will dichromate and chromate difference also I told you. K2Cr2O7 and K2Cr O4. That is the difference between potassium dichromate and potassium chromate. Understood? So sometimes they are asking these type of questions. Now better look here what they are asking, another question. Just note down the next question. Everyone, children, plus note down please. First note down this content. Yes, beta. Note down this part. This is very important. Let's check this one out. An element X forms an oxide with formula X2O3. Understood? An element X is there. It is forming an oxide. It is forming what, beta? Thank you so much, beta. Thank you so much. So now look here. An element X is forming an oxide. Molecular mass is there. Formula unit mass is there. Fine. You just carry forward this atoms and molecule chapter, beta. Yes, but I'm seeing that only. Iron sulfate part is there. How they are writing? What is ions they have given? What is molecules they have given? Hmm. Yep. Most of the chapter part we have covered already, and we reached what is molecule we have finished, what is atom ion finished, what is ions we have finished, positive and negative ion part we have done, crisscross rule we are doing. After crisscross rule, molecular mass is there, and formula unit mass. That's it. Okay, beta. Molecular mass and formula unit mass. These are the two topics left. But first, beta, we are going to finish this one. Now, look here. Shall we go? So, molecular mass and formula unit mass. So, valency is X2. Correct only. So, what they are telling that can element X forms an oxide with X2O3. Okay, state the valency of this. So now we need to understand here, whenever crisscross rule is there, how we are writing the crisscross rule. So X2O3 is there. X2O3 is there. When X2O3 is there, so now let's check this one out. X2O3. Now how to write? Now X2O3. How it is made? Come on, go for a flashback. That means X part has 3. So here it is coming 3 plus. O part is electronegative, so it will become 2 minus. So only. So what is the valency of X? Valency of X is 3 and valency of O is 2. Understood? Valency of X, so always the one which is less electronegative is written in left, the one which is more electronegative is written in right. That's the biggest rule. The one which is less electronegative is written in left, the one which is more electronegative. So positive part is written in left and negative part is written in right. Okay, and here the plus and minus, so plus will be written here, minus will be written there. I hope you might have understood this part beta. So now next section what we are going to do, this is plus 3 and minus 2. I hope very good. So beta, this is the thing. Now what is the next part of the question what they are asking beta? Can we check what is the next part of the question what they asked? So let's go for it. The next part of the question, what they're telling, state the valency of X. So what is the valency of X? The valency of X is coming as 3. Now write the formula of chloride, sulfate, nitrite, phosphate of X. So now one by one we are going to write chloride of X. So if chloride of X, somebody will ask, how we are going to proceed for chloride of X, correct Ruchi? So chloride of X, how to write beta? For chloride of X, X, right, we know it is plus 3. Now chloride means it is 1 minus. So if we will do crisscross, it will become XCl3. Then it will be coming as XCl3. It will be coming as how much beta? XCl3. This is chloride. Understood? XCl3. This part is coming as what beta? XCl3. Now next section. Now sulfate. When we are talking about sulfate, XSO4 2 minus. So this is 3 plus and this is 2 minus. So now this will come X2SO4 3. Done. So this is coming as this one, sulfate. Now nitrate. Nitrate is minus. So now we are going to go for nitrate. X will be 3 plus nitrate and O3 minus. So it will become 1 minus. So it will go crisscross. It will become X and O3 whole 3. NO3 whole 3. That is considered as what beta? NO3 O3. So when you are writing NO3 O3, hello? Yes? Anupuram online is there. Yes. Come on, note down this one, beta. Note down, please. Very good. We'll go for the next one. We'll go for the next one. This is exactly X2SO4 whole thrice. So this is most important. X2SO4 whole thrice. Now beta, next one is what? What is the name? After that nitrate, it is called phosphate. So PO4. PO4. PO4, how we are going to handle? X is 3 plus. PO4 also having 3 minus, minus 3. So it will become 3 minus. Understood? So it will become X3 PO4 3. Now beta same ratio is coming, 3 is to 3 cancel. So we can write X PO4. XPO4 or XPO4 without bracket also we can write. XPO4 or without bracket also we can write. That's the most crucial section of it. Understood? So now beta, this is the most important part we have done. Now molecular and equivalent mass. This is a very important thing. So atomic, molecular and equivalent mass. Now we are going to the most crucial section of it. So what is atomic mass? The mass of an atom is considered as its atomic mass. So an atom of an element is so small that it is having, time up, sunset over, no, done. An atom of an element is so small that its mass cannot be determined even with the help of most sensitive balance. Yes, now we cannot be able to determine it. Okay, so that means what? Atom is very, 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 very small. Okay, so at the same time, gram is too big a unit for expression, the mass of an atom. How can we? How can we weight atom in gram? Gram is a very big unit, correct, Navita? So this difficulty was overcome by introducing the concept of relative masses. Understood? Gram we cannot write because one atom, how can we? Because atom is exactly very, very smaller unit of element. So since atom is the most smaller unit of element, we cannot be able to write in gram. Understood? So one atom, how can be it is coming in gram? So what we are trying to do, we are going to relate it and we are going to write the concept in terms of relative mass. In terms of what? Relative masses. Understood? So initially, hydrogen atom being the lightest was chosen as standard. Got it? So what they did, beta? So they wanted something to relate. Okay, like comparison. Relative means what? I am relating you with me. That comes under relative mass. Got it? So there was a state of comparison. Okay, fine, I can compare this with this. So that's what is exactly. So initially, hydrogen atom being the lightest was chosen as standard. So what they did, they chose it as a standard. Okay, now after that what happened? They choose this as a standard, but the number of times the atom of element is heavier than hydrogen was taken as its atomic mass. According to that, it could be expressed. See, what they did is, now where it failed, I want to tell you. Okay, where it failed, I want to tell you. See, what they did is, hydrogen is the most lightest element. Okay, now what they did is they wanted to take hydrogen as a comparative part, relative part, and with the help of the hydrogen they wanted to find the mass of the remaining other elements. Okay, so what they did, they wrote the formula atomic mass of an atom of the element by mass of hydrogen atom. So like this they wrote. First, how they related, beta? Mass of atom of element by mass of hydrogen atom, mass of atom of element by mass of hydrogen atom. So in 1961, the most common isotope of carbon was chosen as a standard as its mass was fixed as 12 unit. Now beta, after that what happened? Since atomic mass of hydrogen was very, very small, see, hydrogen is very, very small, so what happened? Very big element comparison or relativeness was not coming so accurate. So what they did is, did is they relieved it. After that what they did is they wanted to take carbon. So they wanted to take carbon, and after that what they have done, they have taken carbon as isotope. Okay, so in 1961 the most common isotope of carbon they have taken to find the relative mass. Until then, now we are itself using carbon only to find the relative mass. So since hydrogen was small and hydrogen isotopes were there, and hydrogen was relatively in one side where it is exactly having dual character. It can be electropositive, electronegative. Many features of hydrogen were there which was unable to be featured by taking it. So what they did is they took one isotope of carbon, and that is its mass was fixed, and its mass was fixed as 12 units. So this scale in which relative atomic mass of different atoms are expressed is called as atomic mass unit scale. or AMU scale. Understood na beta? So where we are using, so what was the concept? First they took hydrogen to find the relative mass. Why they were taking something to relate? Because in gram we cannot be able to weight, or we cannot be able to find the mass of an atom, because the atom is very simple smallest unit. So it's very difficult to find the content in grams. So what they did, they tried to find the relative mass, and for relative mass they chosen first hydrogen. But hydrogen mass is exactly very small. Its unit is very small. Hydrogen mass was very small. So they chose another element. They choose the isotope of carbon, that is C12 isotope they have to chosen as the standard mass. Understood? And after that its mass is getting fixed. Everybody understood? Come on, say, because this is the most important part, beta. So is it now you are able to understand, beta? It was fixed as 12 unit. Now what they have done, they have fixed it as 12 unit. How much they have fixed it as? How much they have fixed it as, beta? They have, how much they have fixed it as? They have fixed it as 12 unit. Okay, in simple tone I am teaching, in the most simplest way I am teaching. In the most simplest way I am teaching. So this is exactly considered as 12 units. So this scale in which relative atomic mass of different atoms are expressed is called as atomic mass unit. Understood? Atomic mass unit scale. Atomic mass unit scale. Atomic mass unit scale. So this atomic mass unit is defined as 1/12 of actual mass of atom of carbon. So if somebody will be asking you what is the mass, so what you are going to say? Yes, 12 units. It was 12 units. And beta, whenever anybody will ask you what is the mass of this, then you have to say the atomic mass unit is defined as what? 1/12 of the actual mass of an atom of carbon. 1/12 of the actual mass of an atom of carbon. So 1 AMU, atomic mass unit. What is the definition of AMU? Note down, beta. What is the definition of AMU? The definition of AMU is 1/12 of the actual mass of an atom of carbon. I hope you might have liked the class. 1/12 of the actual mass of 1/12 of the actual mass of an atom of carbon. 1/12 of the actual mass of atom of carbon. Understood. So this is the definition of atomic mass unit. And you must remember what is the definition of atomic mass unit, beta? The definition of atomic mass unit is 1/12 of the actual mass of an atom of carbon. So carbon 12 isotope. And it is what, beta? It is carbon 12 isotope. And this is one of the most important concepts. It is the pioneer part if you want to know. So definitely you must remember this one. So now we are going to write how to find the relative mass, how to find the relative atomic mass. So mass of an element by 1/12 of mass of carbon atom. So this is the way to find relative mass. This is the way to find relative. Now the number of times the atom of an element is heavier than 12th part of carbon isotope is called atomic mass of the element. This is the this is the actual thing. This is the actual definition of atomic mass. This you must remember. So how to get the atomic mass, beta? The relative atomic mass of an atom of element is equal to 1/12 of mass of carbon atom. So this is a way to write down the content. So this is atomic mass of few common element we are going to check. But this one you please note down in your note. This is one of the most important thing. So how to get the relative atomic mass? Take out this one, beta. I hope you might have understood, beta, how to write down this one. So number of times the atom of an element is heavier. Means how much number of times the atom of element is heavier then 1/12th part of carbon 12 isotope is exactly called as atomic mass. 12th part, got it? 12th part of atomic mass of element. This is exactly considered as relative atomic mass. This is considered as what? Relative atomic mass. This is considered as what? Relative atomic mass. Note down beta. So relative atomic mass, whenever you are writing mass of atom of the element by 1/12th mass of carbon atom. And beta, relative atomic mass is mass of an atom of given element by 1 AMU. And 1 AMU is 1.6 into 10 to the power minus 24 gram. Till here you write. Next class we are going to compare it and we are going to find how atomic mass is exactly found. Okay, because this is a very sensitive part. Once you will understand gram atomic mass, relative atomic mass, miss, my work will be over. After that you will teach others. You will say, hey, what is this? This is now molecular mass we have to finish. Molecular mass is one topic, and then gram molecular mass, and this was the formula mass, that is molar mass. This was the last concept. So one another class we are going to finish this part beta. Okay, so this section I'm going to teach in the next class. One more last class. Bye. What is this? Yes ma'am, what happened ma'am? I'm coming. Just 1 minute.